Hi, good day everyone. Today we're going to discuss the first law of thermodynamics. At the end of this video, you will learn how to calculate work done by a system when its volume changes, how to interpret and use the first law of thermodynamics. What are the four important kinds of thermodynamic processes, and why the internal energy of an ideal gas depends on temperature only, and what is the difference between molar heat capacities, say at constant volume and at constant pressure, and lastly is how to analyze adiabatic processes in an ideal gas. A steam locomotive operates using the laws of thermodynamics, but so do air conditioners and car engines. Every time you drive a car, turn on air conditioner or cook a meal, you basically reap the practical benefits of thermodynamics. So what is thermodynamics? It is the study of relationship involving heat Q, mechanical work W, and other aspects of energy. I will call this one as U. So any aspects of energy and energy transfer. Okay? So it is the study of relationship involving heat, work, and other aspects of energy. So this is an example of thermodynamic process. This is a car engine. So in a car engine, heat is generated by the chemical reaction of oxygen and vaporized gasoline. So asa ma-generate ang heat, so basically diri dapit. Okay? So mag-mix ang air ug ang gasoline here, and ignite nimo using spark plug, then nakoy ma-generate nga heat dira also here, no? Nakoy ma-generate nga heat dira. It is due to the chemical reaction of oxygen and the vaporized gasoline. And due to this heat, the heated gas inside this engine pushes on the pistons within the cylinders. So ang mahitabo is when the heat is generated here, this movable piston will move, and this movable piston will do mechanical work that is used to propel the car. So that is why mo move mo ang car because of this. So nakoy heat na generate dira, due to that heat mo move mo ang piston, and kaning then you're doing mechanical work, and then mulihog mo ang car. Okay, so this is actually an example of a thermodynamic process. So we'll discuss this later. What is a heat engine and what is a refrigerator? Okay. Next is let us define thermodynamic system. It is any collection of objects that may exchange energy with its surroundings. Say for example, the popcorn in the pot. This is an example of thermodynamic system. In the thermodynamic process shown here, dari, okay, heat is added using the stove, nag-add kag heat, okay, to the system, and the system does work on its surroundings to lift the lid of the pot. Okay, so this is an example of a thermodynamic system. In a thermodynamic process, we have to take note that the heat and the work can be positive, can be negative, and can be zero. Take note, in a thermodynamic process, changes occurs in the state of the system. When I say state, you're changing, say, from state 1 to state 2, for example. What will you do is you need to add or remove heat, do some work, and so on. Then, na mag-change yung state, say, from state 1 to state 2. Say, for example, your state 1 is niwang. This is your state 1. And then, gusto nimo nga magpatambok, tambok. This is your state 2. So, state 1 is niwang imong state. Then, state 2 is gusto kang patambok. Okay? So, by adding some heat or doing some work or removing some heat or what, ma-change nimo ang imong state from niwang to tambok. So, depende sa quantity nga Q, and depende po sa imong work in order to change your state. So that is a thermodynamic process. And we have to take note sa ito, Q and work can be positive and can be negative. Okay? And can be zero. So kano sa positive ang Q, kano sa negative ang Q, kano sa positive ang work, kano sa positive, negative ang work. So Q is positive, take note of this, take note sa ato ang figure. The green one is your system and ang gawas is your environment or your surroundings. Okay? So Q is positive when it enters the system. Okay? So kung mag-add ka og heat sa system, then Q must be positive. And negative when it leaves the system. Kung mag-remove ka og heat, this one. Kung mag-remove ka og heat sa system, then your Q is negative. Take note of that. Kung mag-add ka og heat sa system, Q is positive. Kung mag-remove ka og heat sa system, Q is negative. How about sa work? Kano sa positive ang work? Work is positive when it is done by the system. So kung ang magbuhat sa work is ang system, then work must be positive. Work is negative when it is done on the system. So maybe ang environment mo yung nagbuhat sa work. So when it is done on the system, then work done is negative. So take note of that. Work is positive, work is negative, depende sa direction sa imong paggawas ba siya o pasulod. Kung ang system ba naglihok or ang system ba ang nagbuhat or ang system ba gibuhatan ng work. Okay? So Q can be negative, can be positive, can be zero. Work is also pwede po siya ma-negative, pwede ma-positive, and pwede ma-zero. So take note, careful of the signs. Okay? Now, how are we going to calculate work when there is change in volume? So what is work during volume changes? So kano sa mag-change ng volume? Say the best example of this is we have a thermodynamic system, a quantity of gas enclosed in a cylinder with a movable piston. So na ko yung cylinder, this is my cylinder. Okay? And then na ko yung movable piston, the blue one, okay? This is your movable piston. So move siya, it's either pa left or pa right. Bali. Move siya pa left or pa right. Okay? Take note of that. So, when one such molecule collides with a surface moving to the right, so for example, the volume of the gas increases. So, ang volume sa sulod, kani? Ang volume sa sulod will increase kung ang mga piston kay move siya pa right. Take note, the volume of the gas increases, then we can conclude that the molecule inside the cylinder does positive work on the piston. So, when the volume increases, the molecule does positive work on the piston. How about kung ang piston kay move siya pa left? For example, if the piston moves toward the left, as in the figure shown here, the volume of the gas decreases. Mugamay ang volume sa sulod. The positive work is done on the molecule during the collision. Hence, the gas molecule do negative work on the piston. Since the gamay ang volume, the decrease ang volume, then the gas molecule do negative work on the piston. Okay? So take note sa direction or sa sign sa imuhang work. And based from that, we can actually derive the expression of work, which is equal to this expression. Very simple equation. Work is an integral of pressure times the change in volume dV. Again, work is defined as the integral of pressure, any pressure, okay, times the change in volume. So when there is change in volume, then there is work. Take note of that. The work done in a volume change is equal to this one, where V1 is your initial volume and your V2 is your final volume. Okay? So Sign lang, no? Sign lang kayo nga expression. It is an integral of pressure times the change in volume. Okay? Integrated from the initial volume V1 to initial volume V2. So, kano saan siya ma-positive, kano saan ma-negative? Look at the limit. Okay? Depende kung ahay mas dako aning V1 o ang imong V2. Okay? Ahay mas dako sa V1 o sa V2. So, pwede sa ma-negative. Work, pwede ma-negative. Pwede po siya ma-positive. So, tanaw na ito dire, no? Okay. In this PV diagram, take note of this. In this PV diagram, you are changing your state from state 1, okay? You're changing your state from state 1 to state 2, okay? So, how to change state 1 to state 2? In this diagram, ang gibuhat niya is, you decrease the pressure, decrease ni mga pressure from P1 to P2, okay? And you increase the volume from V1 to V2. Since there is an increase of volume, then the work done is positive. Take note, work done here is positive. And the work done is just the area under the curve on the PV diagram. So basically, kaning orange mo ni, kaning part dire, kuhaan mo ning area, muna ang value sa imong work. Take note ha, sa calculus same lang, no? Kung mag-integrate ka function sa calculus, no? Sige na ko nga ni. Then the area under this curve is just the integral of this. The integral of this function, say f of x. The integral of f of x dx, say from initial to final. So kung kuhaan na ko ang work, based lang sa PV diagram, ani, kuhaan na ko ang work, then the work done under the curve, the work done is just the area under this curve. So makuha na ko ang work done under that curve. And that is equal to what? Work is equal to P dV. So positive siya, why? Nganong positive gani siya? Because ang imong pag-change sa imong pressure and volume, volume for example, is gi-increase nimo ang volume from V1 to V2. So when there is an increase of volume, then work is positive. How about mo decrease imong volume? Say for example, this is my initial state 1, and my final state 2. The direction is going there, okay? Okay? So you decrease the volume from V1 to V2. You decrease nimo ang volume from V1 to V2, thus the work done is negative. Okay? There is a decrease of volume from V1 to V2. Tanaw nimo ang arrow ha, take note, kuan mo sa arrow. Ang arrow is going there. You decrease the volume, then the work done is negative, and the magnitude of that work done is just the area under this curve. Same lang yapon, no? Kung ano mong area under this curve, and the sign of your work is negative. So, changing state 1 to state 2, you decrease the volume and you increase the pressure. The work that now here is negative. Okay? So, kabalo na tayo mabasa sa PV diagram. Okay? Kabalo tayo mabasa sa PV diagram dapat. The area under that curve is your work done sa PV, sa atong PV diagram. Okay? How about this? In this figure, it is a system undergoing an expansion with constant pressure. Tama ba? Na ko state 1, this is my state 1, and then you increase the volume while your pressure is constant. Same lang imong pressure. Okay? And then you are changing your state from state 1 to state 2. And as I said, work is just the area under this curve. And at constant pressure, dali lang din mo ma-integrate ang PdV, right? At constant pressure, so may tabo na ko'y work is equal to integral of PdV from V1 to V2. Since this is constant, pwede nimo siya ipagawa sa integral. Okay? Integral of dv from v1 to v2. And this is just equal to what? Integrate this one. This is v, integrate from v1 to v2. So you will get this p is equal times v2 minus v1. So the work done at constant pressure, take note, at constant pressure is equal to PV2 minus V1, where V2 is your final volume and V1 is your initial volume. And kung lantawon lang ni mga PV diagram, it is just the area of this kaning rectangle there under the curve. So, special case na siya, no? At constant pressure, ma-integrate ni mo daan ang integral PdV, and that is equal to P times V2 minus V1. Very simple. Okay. Work done is positive because you increase the volume. You increase man yung volume, so work done is positive. So kung ang direction na po mo sa arrow is going there, then work done is negative. Okay? Decrease the volume, work done is negative. Okay. Say for example, this is an isothermal expansion of an ideal gas. What do you mean by isothermal expansion? Isothermal is your temperature is constant. Okay? Your temperature is constant. So, how much work does the gas do? Kilala ko no ang work does the gas do? Take note, solution. Work is equal to integral of P dV integrated from V1 to V2. And recall, in an ideal gas, this is an ideal gas, take note. Recall, P is equal, PV is equal to nRT. Okay, and this is an isothermal expansion where your T is constant. Okay, so P here is equal to nRT over T. I-plug din mo na siya dari, you will get what? Okay, work is equal to P na ko is nRT over P dV integrate from V1 to V2. Take note, nRT is constant. Constant pa na akong temperature, no? Ako'y nRT. Mapagawas na ako sa integral. Integral of dV over V from V1 to V2. Ilagay ni dV over V nga integral. This is ln. Okay? So I have nRT ln of V from V1 to V2. And this is equal to what? Work is equal to nRT, okay, ln of V2 plus, it's minus ln of V1. Kung ako'y ln A minus ln B sa math, ln A minus ln B, this is equal to ln A over B. So this can be written as what? Okay, n RT ln of V2 over V1. So this is now the work done at constant temperature, and the volume changes from V1 to V2. So this is now my work done by the gas. Very simple, right? It's the work done by the gas. Okay, work depends on the path chosen. So, magdepende kung unsa kadako ang work done sa imo ang system, magdepende siya kung asa ka moagi sa imong path. Say for example, we have 4 states here. I have state 1, this is my state 1, my state 2, state 3, and state 4 for example. And you want to change your state from state 1, i-change mo ang imong state from state 1 to state 2. And there are many different paths or 3 different paths sa diya, no? Na ko yung path 1, sugod sa ka sa muagi sa ka sa 3, tapos mo adto ka sa 2 para maabot ka sa 2. This is my first path. Or pwede ka muagi diri sa ubos to state 4, then maadto ka sa state 2, or mo shortcut ka from state 1 padulong sa state 2. So lahi-lahi ni siya nga process. And take note, ang work kay gadepende kung unsa nga path imong gipili. Diri ba ka sa taas nga path, kani nga path? Diri ba ka sa ubos nga path o diri ka sa shortcut nga path? So magdepende ang work done sa path nga imong gipili. So take note, kung diri ka moagi sa ubos, first is you are decreasing the pressure at constant volume, and then you are increasing the volume at constant pressure P2. Kung diri ko sa taas, first is i-change nimo una ang volume, i-increase nimo ang volume at constant pressure P1, and then next is i-decrease nimo ang pressure at constant volume P2. Or kung diri ka sa path, sa shortcut na path, i-change nimo ang pressure at the same time you change the volume. So magdepende sa path. Take note ang work done. Okay, so tanawon na to, no? Isa-isahon na to. We have to take note that kung sa itong work gani, this is the area under the curve. Okay, area under the curve, and magdepende ang sign. Increase ba nimo ang volume, decrease ba nimo, magdepende ang sign sa imong work. Okay? Direct sa path 1, na ako'y changing from state 1 to state 2. Akong path nga giagyan is from initial state 1 to initial state 3 to initial state 2. So kani sa taas nga path. Okay. From state 1 to state 3, gi-increase nimo ang volume at constant pressure. So since na-increase sa volume, then there is work, and the work is just the area under this curve. So muna ang imong work done. Okay? From 3 to state 2, there is no change in volume, so therefore kaning nga path dere is wala koy work done dere. Nako. So wala ko'y work done dari. Ang nalay work done is only this one. Kaning change nyo from state 1 to state 3. And take note, the work is just the area under the path. Okay? So mas dako sa area. Take note, mas dako ning kaning gisitan nga part. Dako ni siya nga area. Ba? Kung diri ko moagi sa taas, mas dako siya nga area. Kung diri ko moagi sa ubos, notice ang area nako na lang is gamay. Then the work done is gamay na po. Sakto ba? Okay? So, kung diri ko moagi sa ubos, first is gi-decrease nimo pressure at constant volume. So, kaning path, there is no work here. Wala ko'y work done dira. While from state 4 to state 2, the work done is just the area under this curve. So, gamay kayo ang work done. Kung moagi ko diri, gamay ang work done niya. Kung moagi ko sa taas like this, dako kayo ang na-cover sa iyang, dako kayo ang work done. Okay, so notice ang work kay gadepende siya sa path na imong gipili. Okay, and then for path 3, the work done is just the area under the path. Okay, increasing the volume from V1 V2 while decreasing the pressure from P1 to P2. So sa kanila nga figure sa tulo, kaning nga tulo, makibalaan nato nga lahi-lahi ang work done sa lahi-lahi nga path nga imong giagyan. Although same ra og initial ang same ra mo ang goal. Ang goal nimo is you're changing your state from state 1 to state 2. Same ra imong goal, changing state 1 to state 2, pero lahi nga path imong gigamit, so lahi ang work na imong makuha. Okay, take note of that.